reaction, what we generally think is that there will be 50% inversion and 50% retention. Although it is like in most books, they have mentioned it like 50% retention and 50% inversion. But in actual, in experiment, in labs, it is not the case. In labs, while we are doing experiment, what we usually observe is inversion is slightly more. And the reason is due to this ion pair effect. What is happening basically? Uh, have we discussed this one or not? SN1 reaction, ion pair one.
Sir.
Yeah, we discussed this. This question, okay. Mm, So tell me the answer for this question fast. What should be the product? Which one is the living group here? You have to identify first. Is this living group, this living group, this living group? Which one is the living group? Which one is the living group? This bromine, right? And out of these
Uh,
two,
yes, sir.
if out of these two, if you are dissolving it in a solution and converting into ion, then it will convert like this. And this Cn negative will act as a nucleophile and it will attack and it will remove this. So your product is
Yes,
going
sir.
to be Cn and H like this, and NaBr will be like removed. In this one again, this OH will attack and Br will be removed. Simple
Yes,
as
sir.
that, right?
Yes, sir.
Now let us talk about this. Predict the product of the following SN2 reaction. These are SN2 reaction. You have to tell the product. So simply, what you will observe, this O negative will attack and remove the Cl and give you the simple inverted product. Walden inversion, right?
Yes, sir.
O will attack like this. Similarly here, it will attack in this manner and give you the product. pH means this phenylalanine. Similar, okay. And here, what we are going to observe, this OH will attack here and remove this, and you will get your product plus Cl. Right? Why we are
Sir.
not attacking here? Because if I attack here, I will get the same product.
Yes, sir.
Okay. This is again the same, the continuous, like the fifth part of this same motion. You have to again do the SN2 reaction. You will do what? This Cn will attack at this carbon, right? Here it will attack
Yes,
again
sir.
at this carbon and again at this carbon and here. This one you have to be very specific because here they have shown the stereochemistry involved in inversion while you are doing the SN2 reaction. Or a question is whether you are going to do an SN1 reaction or SN2 reaction, SN1 or SN2. As in question it is given SN2, then we have to do the SN2 reaction. SN2 reaction is basically one-step reaction. The nucleophile will attack from the back side and the product will have opposite symmetry, stereochemistry basically. If the bromine
Yes,
was
sir.
in front, then the nucleophile will go at the back side and it will be attached like this, right?
Yes, sir.
Again, this is a question, which one of these will have the fastest, like highest reactivity? You have to think about the aprotic solvent. In aprotic solvent, what is happening? Or try to think about it, like which one will have the fastest?
Sir, sir, iodine
Good.
will be the fastest for iodine.
D1, right?
Yes, sir.
This is the question again. So what is happening here? I told you if they are mentioning solvolysis or hydrolysis, they are indicating that the reaction is going to follow SN1 mechanism. right? If they have mentioned
Yes,
hydrolysis
sir.
or solvolysis, then you can say the reaction is somehow more preferably going to follow the SN1 mechanism. So to double check it, what we can do? Hydrolysis means H2O is going to act as a nucleophile because in hydrolysis, our solvent is water. And whenever we are using this term lysis, it means our solvent is going to act as a nucleophile. So H2O is relatively a weaker nucleophile because it is neutral. So what we studied, if our nucleophile is weak, then it will prefer SN1 reaction because SN1 reaction do not depend upon the strength of the nucleophile. Also, they have mentioned the hydrolysis part. So the all of this thing is indicating the reaction is going to follow the SN1 mechanism.
SN1.
So the first step is what? Self-ionization. This chlorine will be removed and here we will have positive charge, right?
Yes, sir.
Then we have to attack H2O. The question is there any position where we can shift hydride or methyl to produce a even more stable carbocation? Suppose here, if I am removing this and I am putting a positive charge here, this is a which degree carbocation? 3 degree,
3 degree.
I guess.
3 degree. 3 degree.
3 degree. If possibility is like the H2O can attack here. But if somehow, if I'm doing this, suppose if I'm shifting this hydrogen here and I'm producing a positive charge here, this positive charge here is again 3 degree or not,
Yes, sir.
but it is resonance stabilized due to the donation of electron density from the benzene ring. So this position is even more stable than this one. So the major product is going to be this one, and minor
Sir.
product we cannot neglect it. The minor product is going to be this one. So what we are going to get as an answer? A mixture of 1 and 2,
Mixture of 1 and 2.
right? Why we are not getting 3?
Sir, because uh, sir, because CH3 is not uh, SN1 real.
See, we can do that. We can do that. We can shift methyl as well. We can produce a positive charge here. But what will be the issue? Here we have electron withdrawing group, and here we have electron donating group.
Yes, sir.
If you have a positive charge here and your neighbor is someone who is pulling the electron density even now. Suppose you are very poor and your neighbor is someone who is still pulling the money from you. So you will get even more unstable, right?
Yes, sir.
So this is the reason. Here we had electron donating group. So the positive charge that was generated here was getting stabilized. But here we have electron withdrawing group. So this is not the case here. So the only possible options are 1 and
1 and 2.
okay. So this is again some question. Uh, this tosyl chloride, I told you, it is a very good leaving group. We use it to convert bad leaving group into good one. So this OH will be converted into what? CH3, CH,
CH.
TSCl, right here, and CH3. Okay, now if you are reacting it with NaNA3, this N3 and Na positive, this N3 negative will attack and it will remove it. So you will get CH3, CH, N3, CH3. That's it. Right. This is your A.
Yes, sir.
This is your B. Similarly, here again it will attack in this manner. Or the thing that you should keep in mind. This is a 3 degree substrate. So we will follow SN1 or not. What should
Yes,
we do
sir.
here?
SN1.
Think about it. I may be wrong. What we have studied so far.
If it is 3 degree, then SN1
This
reaction.
is your homework, right? I will check this question tomorrow class. You have to find the answer. Whether we are going to do SN1 or SN2 with explanation, right? This is your homework.
Yes, sir.
Okay, so the next topic is internal nucleophilic substitution. What do we mean by internal nucleophilic substitution? Here, we are not attacking our substrate with an external species. We will attack our substrate with something which is already present inside it. So, for example, what is happening? Case 1, retention of configuration. You have an alcohol and you are reacting it with SOCl2. Which type of reaction is this? This is a name reaction, very important name reaction. I told you. Which reaction is this?
Sir,
We have studied this. The side products are gaseous product which will be removed from the reaction. That makes it a very efficient haloalkane production reaction. You told me, like, you remember it or not? Darson, Darson method. Does it bring any, like, does it ring any
sir,
bells?
chloride.
You remember the Darson method where we reacted alcohol with SOCl2,
Yes,
right?
sir. Yes,
So
sir.
I mentioned,
Thioacyl chloride.
huh, I mentioned something, right? If we are using pyridine, then we are getting inversion. If we are not using pyridine, then we are getting retention. I told you something like that in that class, right?
Yes, sir. Yes,
So
sir.
now we are going to understand the explanation of that. Suppose you are using only SOCl2, you are not using pyridine. So what will happen? This electron density, this lone pair will attack here. Why? Because of the polarity, the dipole, partial positive, partial negative due to electronegativity. The electron, sorry, this bond will go up because it has to go up because, like, sulfur, like if I
Yes,
am
sir.
making a bond here, the electron will shift bond. So then it will push the electron back in the bond and this chlorine will leave, right? And here this positive charge will be stabilized by sacrificing this hydrogen. So HCl will be removed. Now, internal substitution means this chlorine is now going to attack at this carbon and internally you will get your product. This is retention. You are not getting inversion. This is your retention. So what you understand here? In your exam, they are not going to ask you the mechanism. They will simply give you questions and will mention the reagents. Like they will simply say you are reacting alcohol with SOCl2 alone. The product is going to be a retention product or inversion product. So without pyridine, you are going to get retention, right? Is it making sense? If you have doubts, please ask. Do you have any doubts, Ali? No.
Hello, sir. Can you hear me?
Yeah. Do you have any doubts regarding this topic, like why the retention is happening? Because the attack is from the internal uh, nucleophile, like internal reagent, you can say.
Yes, sir.
Now, the inversion one. If you are using pyridine, then you will observe inversion. This is a proper example of SN2 reaction. Inversion, right? So what is happening? Again, the initial stack is same, but after this, once you get this product by sacrificing hydrogen and shifting this electron density to remove chlorine, then your pyridine will attack. Pyridine will attack here, right? Then Cl will be removed. Now, after the attack of this pyridine, again I told you something. If some element is donating its own electron pair to some other species, the positive charge is going to be present or develop on the species which is donating its lone pair. So here we have positive charge. Now, in the reaction, I have this chlorine now. Okay. After the attack of pyridine, this chlorine is removed, and this chlorine will attack here, and it will exclude this, and you will get your inversion product, right? So what you must remember from this, if you are using only SOCl2, you will get retention. If you are using SOCl2 with pyridine, you will get inversion, right?
Yes, sir.
Now our elimination, oh sorry, substitution is complete. Now we will talk about elimination. In elimination, we have a like general idea. We discussed about it in the initial classes, I guess. In elimination, we use a base, right? And base main task is to remove an proton, right? And it produce alkenes. We talked about this, I guess.
Yes, sir.
So we will have a base. Suppose Y is an hydrogen, it will abstract that hydrogen and give you a alkene. This is elimination basically. Elimination is of three types basically: E1, E2, E1, CB. This E1 and this E2 are similar to SN1 and SN2. We will talk about it. Okay. E1 is exactly similar to SN1. Although E2 and SN2 have slight differences, but E1 and SN1 are almost same. The only difference is if you are increasing the temperature, you will get a E1 product. And if you are doing the same reaction with cold conditions, then you will get SN1 product. We are going to talk about all of them. So how many types of elimination we are going to discuss? E1, E2, and E1C, right?
Sir, the third one is E1C2,
E1CB, conjugate base,
E1CB. Okay.
right? So
Yes, sir.
just a note, if you are seeing aqueous KOH written anywhere, if you are seeing aqueous KOH written anywhere, then you have to assume it as a nucleophile and it will cause substitution. But if you are seeing alcoholic KOH, then it is going to act as a base and will lead to elimination, right? In your NCRT,
Yes,
they
sir.
have a specific question: why aqueous KOH is nucleophilic and alcoholic KOH is not. So we'll talk about that as well. Now, dehydrohalogenation. What do we mean by this? Dehydrogen, that means we are removing a hydrogen as well as halogen. So base will abstract a proton and the bond will be shifted and converted into a double bond and your leaving group will be eliminated. This way you will get your alkene, right?
Yes, sir.
Base will come and this. Similarly, like here as well, base will come and it could either take a proton from here, it could take a proton from here, could take a proton from here. All of this possibility will lead to a same product, right? So you can take proton from anywhere. For this one, we have taken the product proton here and we got this product. Some common bases that are used in elimination are these. You can use KOH ethanol or alcoholic KOH. You can use this methoxide, sodium methoxide, sorry, ethoxide, or you can use tertiary butyl oxide or NaNH2. You will use these bases or you will see these bases frequently, so you should be aware of them, right? These are some strong bases. So let us talk about specifically E2 elimination. Okay, E2 similar to our SN2, it is a biomolecular reaction. So what is special about biomolecular reaction? In biomolecular reaction, our rate depends on substrate as well as base. In case of SN2 reaction, it depends on substrate as well as nucleophile. In case of elimination, it will depend on substrate as well as base. That's why it is biomolecular reaction. Is it clear what I just said? Why it is biomolecular reaction? Because it depends on both the base as well as substrate.
Yes, sir.
Now, this is again example of elimination reaction because we are using base and we will get our alkene like this. This is my base. It will abstract the proton and like you will get your alkene. Here we are having which type of transition state? In elimination, we have alkene transition as transition state because here we are having alkene character or not.
Yes, sir.
Now, the elimination is happening at which position? Beta elimination, you can say. This is your alpha carbon because it is directly attached to bromine. And the next carbon is beta carbon. And from beta carbon, you are going to eliminate what? Hydrogen, proton. And you will get your alkene. Again, it is similar to our SN2 reaction. So it is again a single step reaction. You are not going to see any intermediates. Okay. Base will come,
Yes, sir.
abstract proton and give you product. That's it. Now, we also talked about something like uh, base and nucleophiles are not different. If a species is a nucleophile, it can act as a base as well. If a species is base, it can act as a nucleophile as well. So it all depends on the conditions, right? I told you in elimination, we require what? high temperature condition, because in elimination we have to break more number of bonds. Do you remember this?
Sir.
Hmm. So if we are doing elimination, then there must be some issues with SN2 reaction. We are not able to do the SN2 reaction. That's why we have to opt for E2 reaction. So what could be the possible issues with SN2 reaction? We are going to see. SN2 reaction is best for 1 degree substrate, right? If you have a 1
Yes,
degree
sir.
substrate, the SN2 reaction will be the fastest. Why? Because SN2 reaction, we have to attack from the backside. If our substrate is hindered, if it is surrounded by so many people, you won't be attacked with more proficiency. So in this case, our substrate is 3 degree. SN2 chances are negligible. In 3 degree substrate, SN2 is not going to occur. So this negatively charged thing is now automatically have to behave as a base. So rather than attacking at the back side because of the hindrance, it will take the H positive from here and it will lead to elimination. Right?
Yes, sir.
You can think it like if you are in a room. Suppose, sorry, you are not in a room. You have a friend who is in a party, right? And the room is packed with people. And your friend is sitting at the opposite end of the room, and you are like entering from this gate, and your friend is sitting there. So you have two options. If you are an introvert guy, you won't be able to go through all these people and like ask your friend to come outside. You will hesitate doing that, right or not?
Yes.
So if you are not reaching your friend directly, you are not able to do SN2 reaction, because in SN2 reaction you have to directly attack. So rather than going to your friend, you can just simply call from the gate. You can ask your friend, come outside, I'm waiting, right?
Yes, sir.
So because you are an introvert, you called your friend at the gate and you did elimination. Why you did elimination? Because room was jam packed with people. You were not able to go to your friend. It was hindered.
Yes, sir.
So automatically you have to call them. So this is all about SN2. You could either act as a nucleophile or as well as a base, but it will depend on the conditions. Okay.
Yes, sir.
Now, orientation of elimination. See, the main thing is you have to remove the alpha hydrogen, you have to remove the hydrogen from beta position. The position which is directly attached to bromine is alpha, and this is beta, and this is beta. Here we have two beta positions. So the question is, which hydrogen should be removed, right? You can either remove this one, you can either remove this one. So which one will give you a more stable product? So for this, we have ZSEF rule. It's a Russian name. Some people like write it like ZAITSEF, ZSEF, or some people call it ZSEF. So you can use either of them, though both of them are correct, right? So what does
Yes,
ZSEF
sir.
rule say? ZSEF rule says you will uh, abstract the proton from that carbon, which will lead to a more alkylated alkene, more substituted alkene. For example, suppose if I am attacking from this position, if I am using my base and removing this proton, then it will shift the bond from here and it will remove the bromine like this, or not?
Sir.
And one more thing, this is 1 degree and this is 2 degree, and it will lead to this product. And if I am doing the same thing from here, it will lead to this product. So now the question is, out of these two compounds, which one is more alkylated, which one is more surrounded, which one is more substituted? So you will see this double bonded area, you will see this double bonded region, and you will see at its right side and its left side. If you see on the right side, you are seeing one alkyl group, hydrogen, hydrogen, hydrogen. Okay. But if you are doing the same thing here, you are seeing a methyl group on the left side as well as at the right side. So which one is more substituted?
The second one.
So it will be major product. And you can use one more thing. You can use hyperconjugation. In hyperconjugation, what we see? Number of alpha hydrogen. So to this double bonded carbons, this is alpha, and we have only two alpha hydrogen. But here, these two are alpha carbons, and we have total 6 number of alpha hydrogen. So on the basis of hyperconjugation, you can talk in terms of stability as well. So is this clear? If you
Yes,
have two
sir.
sides, whether you can choose like from right or left, you will choose that side which is giving you more stable product, more alkylated product. This is yours, that's separate. Okay, let us talk about stereochemistry. Just give me a second. See, in E2 elimination, our compound prefer anti-coplanar transition state. For example, if your hydrogen is here, the leaving group should be here, like anti. If your hydrogen is here, the leaving group should be here. So it can easily abstract the proton, and consecutively the double bond will be shifted and your leaving group will leave. It prefer basically staggered or क्या बोलते हैं इसको? Conformation, right? So it will prefer your anti-coplanar transition state like this. What if you have syn coplanar transition state? For example, your hydrogen is here and your halogen is like here in front of it. So this will create repulsion, so it will be unstable. So it will avoid this configuration, right? So
Yes,
if you
sir.
are doing elimination reaction, you will always go for anti-coplanar transition state. This is your energy profile diagram. It is same as our SN2 reaction. I don't think I have to explain it again. I showed you the video as well. What is happening, right?
Yes, sir.
This is same.
Yes, sir.
No single step reaction similar to SN2. No intermediate, no rearrangement. Now this is a bit important. You should focus on it. Factors affecting E2 reaction. See, in SN2 reaction, what we observe, the substrate should be 1 degree, then 2 degree, then 3 degree. But here it is opposite. Why? If you are going for E2 elimination, you will prefer 3 degree halide. 3 degree substrate would be considered. But in SN2, we always prefer 1 degree. So think about it. Let me give you some examples. See, this is same thing, right? OH negative or not.
Yes, sir.
Here it is a 1 degree substrate. In 1
Yes,
degree
sir.
substrate, it will act as a nucleophile or as a base.
Nucleophile.
Nucleophile because it is not hindered. It can easily attack from the backside and give us a substitute product. But here, the backside attack is not possible because these methyl group has their own electron cloud and it will cause hindrance to attack from the backside. Okay.
Yes, sir.
So here automatically this will not act as a nucleophile now. It will act as a base because it has no option to act as a nucleophile. It will directly do what? It will call from outside and it will obstruct the proton and lead to elimination. So
Yes, sir.
as in elimination, we are observing a transition state which resembles alkene and 3 degree alkenes are more stable. That's why the rate of E2 will be 3 degree, 2 degree and 1 degree, opposite of our SN2, right?
Yes,
Concentration
sir.
of strength, concentration and strength of base is important. Strong base will be required because it is a bimolecular reaction similar to SN2. Nature of solvent is not important here. You can take polar, apolar, it doesn't matter for E2 elimination, right? It is slightly different, but the main idea is same, right? Now
Yes,
elimination
sir.
E1. It is like elimination E1 and SN1 is same, like they are brothers. Let us talk about it, how they are similar and where they differ. As it is a unimolecular reaction, it only depends on substrate. The strength of base does not matter here, right?
Yes, sir.
It will depend on substrate. Order of the rate reaction is one. So in SN1, what was the first step? Self-ionization or not?
Yes, sir.
So in elimination, even the first process is same. The rate determining step is same for both E1 and SN1. This is the reason they are very similar. So after self-ionization, you will get your carbocation. Okay.
Yes, sir.
Once you get the carbocation, your nucleophile can act as a nucleophile. Your basically your CH3OH, your methanol can act as a nucleophile as well as a base. In SN1 and E1 reaction, we get mixture always, but the major or minor product will vary depending on the condition. Suppose you are doing the same reaction, you are using methanol, but your temperature is suppose 5 degree. So you will get substitute product. For example, let me draw that product as well. Okay, you will get a substituted product if your temperature conditions are low. But if you are doing the same process, but at a higher temperature, for example, 60 degrees Celsius, you are just basically providing heat. So this methanol will now act as a base and give you alkene. Okay. Suppose in your
Yes, sir.
exam, if in your exam they have mentioned this sign, so you will assume the elimination product is going to be major. But you cannot neglect the SN1 product. It is going to be present there, but the concentration will be minor. They will always go hand in hand. If you are observing SN1, E1 will be there. If you are observing E1, SN1 will be there, but the major and minor product will vary. So let us
Yes,
talk
sir.
about it for a bit more. For SN1 and E1, rate determining step is same. Hence, both occur at same time, but as E1 require more number of bond breaking, it needs higher temperature. At high temperature, E1 is major. At room temperature or low temperature, SN1 is major. We will get both product SN1 and E1, but which is major will be decided by conditions such as temperature and energy. What I just said, right?
Yes, sir.
Competition with SN1 reaction. SN1 and E1 always go hand in hand because the rate determining step is same for both. Generally, elimination is favored at high temperature. This is your energy profile diagram. It is same as your SN1, but the product you are getting here is alkene, right? This is a
Yes,
question
sir.
which will help you to understand it better. Give me a second. I'm thinking of completing this chapter today because we have to start the new one as
Sir, so today's class is till when?
well.
Today's class is till what time?
What? 11:30, 11:30. Like 1 more hour.
Okay, sir.
So see, what is the question here? When the following compound is heated with methanol, several different products are formed. Propose a mechanism for this following reaction. So first thing is you need to identify whether it is going through SN1 or SN2. Okay.
Yes,
So
sir.
how we are going to propose that? So for this one, let me specify this. We have to go through SN1 reaction. So let us think what we can do. So the first step for SN1 reaction is what? Formation of carbocation.
Yes, sir.
You will get your carbocation like this. Okay. Now
Sir.
this is 1 degree carbocation and it is highly stable or not?
Yes, sir.
So because this is highly unstable, we will observe ring expansion. These bonds will be broken from here and it will connect here. We will call it ring expansion. And we will get something like this. Right? Out
Yes,
of
sir.
these two, we have this one more stable because it is 2 degree carbocation now. And it is not like it's not like this product will not exist. This will exist and it will cause some products, minor products. Suppose at this point your nucleophile can attack directly and it will lead to this product. At this product, it is not getting stabilized now. It is just produced and your methanol won't be able to differentiate between a 2 degree and 1 degree. It will directly attack. So at this time, your CH3 will attack this methanol like this, OCH3H positive, and it will sacrifice this bond and give you something like this, right?
Yes, sir.
But this is a minor product because of not much stability. What else? It might act as a base. I told you now, if you are doing SN1, A1 will always be there. So it might act as a base as well. So if it is acting as a base, it will eliminate, like this is your uh, alpha hydrogen, and it will abstract a proton from here and generate alkene. But both of them are minor because of unstable substrate. Then it can do ring expansion. Now it is relatively more stable. So again here it can act as a nucleophile as well as a base. But in your question, as they have given heat, so your major product is going to be the alkene one. Are you getting what
Sir.
I'm trying to say? I'm trying to say is SN1 and E1 always go hand in hand. You are
Sir.
going to get number of products, but the product which is major will depend on the stability of substrate and temperature and energy conditions. Possibilities are like several.
Sir, they can be like equal, 50% and 50%
Which one? Like
formation.
elimination one? Elimination?
Uh, no, sir,
This one?
like both of them. Yes,
No.
can they be like 50%?
No. One of them is going to be always either major or minor.
Okay, sir.
If you are giving heat, your alkene will be major. If you are not giving heat, you are providing cold condition, then your substitution one will be major.
Okay, sir.
Okay. This is again
Yes.
same. Uh, First step is your self ionization carbocation formation. As it is given heat, your major product is going to be the elimination one. Right. Out of these two, this one is going to be major. Can you explain me the reason? We have to talk in terms of Stetsev rule. We have two possible alkene products. This one is major. Why? The
Sir,
substitution
because
one is minor. Mhm.
sir, because sir, because there is more like hydrogen.
Substituted. Substituted. See, you have basically, if you have to do the elimination, you will do, for example, suppose, uh, this is your carbocation, this is your alpha position, this is your alpha position, this is your alpha position, right? Hyperconjugation, we can say.
Yes,
You
sir.
can remove a hydrogen from here, and it will form something like this. You can remove a hydrogen from here, it will form something like this. Or you can remove a hydrogen from here, and it will form something like this. So out of all of them, which one is more alkylated? This has hydrogen on the right side, and left side is the benzene ring. But it has a methyl group, and a methyl. This is more substituted.
Yes, sir.
If you talk in terms of hyperconjugation, for this we have two alpha sites, and here we have two hydrogens.
Yes, sir.
Here we have again two hydrogens. Total four alpha hydrogen. But here what we are observing, this is CH3. This is two hydrogen. This is two hydrogen. Okay. So total
Yes,
how
sir.
many alpha hydrogens do we have here? You
It,
have to see like this. These are your alpha position with respect to your alkene. Here we have 3, 4, 5, 6, 7 alpha hydrogens. So which one is more stable?
uh, the second one.
So it is major. Although both are alkenes, but still we have to pick for the more stable alkene as per Zetsafor. This is the advanced question. It is again very simple. What is happening? Your nucleophile is a strong nucleophile. Okay. And this is a benzyl position. or we can say 1 degree substrate or not. So for strong nucleophile and 1 degree substrate, and you have this dimethyl formamide. This is a polar aprotic solvent. So all of this is suggesting what? SN1 or SN2 reaction? 1 degree substrate, strong
Uh,
nucleophile, aprotic solvent. What all of these conditions are indicating?
sir, SN2.
So you will do what? You will just remove this bromine from here and you will form a inverted product, Walden inversion. So
Yes, sir.
this bromine will go at the back side. Do we have an option like that or not? No, we don't have. We have to create one. Simple Walden inversion, right? Is
Yes,
it
sir.
clear?
Yes, sir. Sir, sir,
Hmm.
can we keep the class till 11?
Do you have to be
Sir,
somewhere?
sir, because I have test, that's why.
You have a test. Let me confirm with my team. They might push your test
Okay, sir.
because you have to complete the syllabus as well. We gave too much time for this chapter once like you had your exam and stuff now.
Sir,
Yeah.
sir, let me ask one, sir. Yes, sir.
Okay, is this question clear?
Yes, sir.
Now factors affecting E1. So it is same as your SN1. The 3 degree will be the fastest, then 2 degree, then 1 degree because rate determining step is same. In SN1 and E1, both you are going to observe a carbocation and 3 degree carbocation is more stable, right?
Yes, sir.
Hmm. So here is a summarization again. E2, 3 degree, 2 degree, 1 degree. E1, 3 degree, 2 degree, 1 degree. And SN1, 3 degree, 2 degree, 1 degree. Only SN2, you will follow 1 degree, 2 degree, 3 degree. Concentration, I talked with my team and they are saying you can attempt the test from 11:30.
Okay, sir.
Okay. So concentration and strength of base is weak base will be preferred because like in the order we saw a base concentration is not important for the rate of the order rate of the reaction, right? So we will prefer a
Yes,
weak
sir.
base similar to our SN1. The nature of solvent is important. Polar protic solvent will be required because carbocation needs to be stabilized. Carbocation is produced in rate determining step, same as SN1. Okay.
Yes, sir.
Now E1 and E2. E1 weak base will be preferred. E2 strong base. Good ionizing solvent. Solvent polarity is not important for E2. Both of them have this 3 degree, 2 degree, 1 degree order. In rate, it only depends on substrate. It depends on substrate as well as base. This is substrate. No particular geometry required. Anti-coplanar geometry preferred. We saw why, because if it is coplanar, then it will cause some repulsion. Rearrangements are common in E1 because in SN1 or E1, we are getting multi-step reaction. We are observing intermediates. Rearrangement is common because we can shift methyl, we can shift ethyl to make more stable carbocation, right?
Yes, sir.
But in E2, we are not observing any rearrangement. It is a single step reaction. It is not stereospecific. It is stereospecific because anticoplanar is preferred. Both are stereoselective. So this is the difference. Do you have any doubts here?
No, sir.
Now, how can you predict whether you are going, whether you should go for elimination or elimination or substitution? Okay, I do the same thing. Suppose you have a 1 degree substrate. For 1 degree substrate, you will always go for SN2. SN2 will be max. if you have a good nucleophile, right? When you
Yes,
will
sir.
observe E2, if your nucleophile or negatively charged species is strong and bulky. If your nucleophile is very bulky, right, it won't be able to attack properly, because if I'm very bulky, I won't be able to attack at a very small place, right? From that too from a backside. So if I'm very bulky,
Yes,
then
sir.
I will automatically go for acting as a base, or you are providing high temperature, so it will again go for acting as a base. If you have 2 degree, then both possibilities are there. You can either go for SN2, E2, you can either go for SN1 plus E1. Why I mentioned this plus sign? Because SN1 and E1 always go hand in hand, right? If
Yes,
you have
sir.
strong base or good nucleophile, you will follow SN2 or E2. If you have weak base or weak nucleophile, you will go for SN1 and E1. If you have 3 degree substrate and strong base, you will observe E1. If you have weak base, you will observe SN1 plus E1, right? Sorry, I made a
Yes,
mistake
sir.
again. It is SNE2, because for E2, which is bimolecular, strength of base is important. We will prefer strong base, right?
Yes, sir.
So we have some questions. You have to tell me the answer. What should be the product here? No, not the product. What should be the group, this X group, which will favor SN1 reaction? You have to think about it. I have like discussed this phenomena already. Like we will observe a carbocation, a positive charge at this bromine site. How to stabilize this positive charge? If we are, which type of group should we attach? Electron donating or electron withdrawing to stabilize a positive charge? So you have to think in that way and tell me the answer.
Sir,
Okay,
electron.
which group? Which is the answer? A, B, C, D. Which one is the answer? The first step is
Sir,
always formation of carbocation.
yes, sir. Sir, A,
Okay, okay. Why?
because it will make it more stable.
How?
Because,
It is a electron donating group, right?
yes, sir, it will donate the electrons and make it more stable.
Positive charge will be stabilized even more. Good. Your answer is
Yes,
A.
sir.
Which of the following is most reactive toward SN1? Okay, now let us see how can you answer this one. Again, for SN1, first step is formation of
Carbocation.
a positive charge will be here. Positive charge will be here. A positive charge is here now. And a positive charge is here now. Which one is most stable?
Sir, first one, A.
Why? You might be thinking in terms of leading group, right? Bromine is the
Sir, it is a
best leading group.
good living group.
See, you like you are somehow right, but the answer is not correct. The answer is C. Now think about it. Why the answer should be C?
Sir, because it is closer to,
Oxygen. Oxygen is
uh,
electronegative.
uh, no, sir,
Hmm.
sir, because
See,
of its position.
no. Although oxygen is electron negative, electronegative groups have a tendency to pull the electron density. It will make it more poor, but as it is just directly at it is on the next carbon. The positive charge is on the next carbon, so it can do resonance.
Yes, sir.
So due to resonance, now this positive charge is stabilized, but the issue is now the charge is on oxygen. So you might say that a positive charge on a more electronegative species is more stable, more
Yes,
unstable.
sir.
So
Yes,
why
sir.
this is still the answer? Because if you are talking in terms of this case, here this carbon had in complete octet. Suppose I am zooming this side. It looks like this. How many number of electrons are here for this carbon?
Uh, 3,
Not bonds, number of electrons.
6.
Is the octet complete here?
Yes, sir.
Octet is not complete. Octet means 8 electron,
Sir, not
right?
complete. Yes.
So in this compound, the octet is not complete. But once you are doing the resonance, once you are doing this resonance, then here what you are observing, all the atoms have their octet complete. Let me show you how. Right now, these carbons have their octet complete. Let us see the oxygen one, whether oxygen has its octet complete or not. It had its lone pair. One lone pair is still intact. So
Yes,
if
sir.
you count the number of electron, two from here, two from here, two from here, six, and two lone pairs. So at this stage, all the atoms in this compound have its octet complete. So it is relatively more stable, right? Due
Yes,
to
sir.
octet complete.
Sir, if the octet was already complete, then the answer would have been A.
No, the answer would have been this as well. Again, because here we are observing resonance. Resonance provides some extra stability.
Okay, sir.
Here we don't have any resonance.
Yes, sir.
Okay, so this is a overview. I have included all of the things like SN1, SN2, E1, E2. So let us go through it again. If you have primary halide, 1 degree halide, SN1 will not occur. SN2 will be highly favored. E1 will not occur. E2 will occur, but you have to use strong hindered base, right? If you are using a very strong or hindered base, very bulky base, then it could perform some elimination even on 1 degree substrate. The same thing, like if you are very bulky, you won't be able to reach the site. You automatically have to take the hydrogen and get settled. Like you have to produce alkene. If you have secondary, all of them have slightly similar chances, but it will depend on the condition. Can occur under solvolysis condition in polar solvent, SN1. SN2 favored by good nucleophile in polar aprotic solvent. You will see the solvent here. Can occur under solvolysis under polar solvent for favor when strong bases are used. For tertiary, favored by non-basic nucleophile in polar solvent. SN2 will never occur in tertiary halide. E1 occurs under solvolysis condition. E2 highly favored when bases are used. Right, so you can go through this and it will make sense after you have revised all of them like SN1, SN2, E1 and 2. If you see this after that, it will make sense. Right. So let us do some
Yes, sir.
questions on the basis of the thing we have discussed so far. So tell me the product for A and product for B. You have to think carefully. Both of the substrates are 1 degree substrate, but this base, uh, basically this negatively charged species, it can act as a nucleophile or as well as a base. So you have to think about it. This is not a bulky base. This is a bulky base. This is a tertiary butyl. Three butyl groups are attached. So this is bulky. This is not bulky. So what should be the products for the respective reactions? Think about it.
Sir,
Mhm. See, if you are a slim guy, I told you previously, if you are
yes, sir.
very slim, you are able to attack from the backside. If you
Yes,
are very
sir.
small, you will simply go and attack from the backside, leading to elimination or not.
Yes, sir.
But if you are very bulky, then you won't be able to attack from the backside because you won't be able to fit there. So automatically you will go for elimination. For elimination, this is your alpha position, this is your beta
Yes,
position.
sir.
So you will abstract a proton from here,
Yes, sir.
and the bonds will go like this, and your bromine will be removed. You will get an alkene. Is it clear
Yes,
now?
sir. Yes, sir.
So let us talk about the next one. What should be the case? Again, think very carefully.
SN1 will take place, right?
Where?
In the C.
Why?
Sir, because it is a it is 3 degree.
3 degree, okay. What should be the product then?
Sir, the same structure, but instead of Br, uh,
Mhm.
MEO.
Okay. What about the next one?
Sir, instead of Br, we'll have double bond.
Okay. Have you considered the temperature condition here?
No, sir.
So try to think again. You have like 1 minute, and if your answer changes, then I will write that answer, or if not, then I will write your previous answer. You have 1 more minute to think about it.
Sir, it will be E1, right?
Hmm.
Because the temperature
Fine.
is high.
Right. They both will have even, but the concentration will vary. Let me show you how. Just give me a second.
Sir, but in the first one, then it was E2, A and B.
Let me mention it. For the A, it was SN2. Here it was E2. Why here we are not using E2? Because our
Because it is
nucleophile,
more.
it is small.
Yes, sir.
Just give me a second. Let me add something to the slides. So, divided to just send it better. Hmm, we did a mistake here. Our nucleophile was this S1. So the answer is this. Right. What else we did wrong? What's the question? I'm getting what I'm doing here because my nucleophile was different. I just replaced it with the same leaving group. It was wrong.
Yes, sir.
Mhm. For this one, your SN2 will be major and E2 will be minor. Okay. For the second one, your E2 is major and your SN2 will be minor. For the rest one, as the temperature is high again, E2 will be higher and your SN2 will be very little. But as now you have a bulky base, so your E2 will be 100% because your base is bulky as well as conditions are in favor of elimination. So you will observe E2.
Sir, so it will
Not
be
SN1.
sir, it will be even, right? NSN1.
No, no, E2. Because see, E2 also favors 3-degree substrate. If you look over here,
Yes, sir.
hmm, where is that? E2 also favor 3-degree. But what is the deciding factor here? If you look carefully, this MEO negative is a strong base, right? And for E1, we have to need or use a weak base. If you are using a strong base, it will automatically lead to what?
E2.
E2. Is it clear? If there was a weak base, then you would have thought about SN1. So here your E2 is major. There might be some possibility of SN2, but very little. But once you have removed your base with a bulky one, then all of the product is E2 product, right? Is it
Yes,
clear?
sir.
Now let us talk about E1CB. This is like again important. From like in your board, they might not ask you this, but if you are going to appear in for any competitive exam, this is important topic. So in the initial lectures, what we were seeing basically, we were observing some bad leaving groups. Suppose OH negative, OR negative, F negative. These were some example of what?
Bad living group.
So we always tried to convert this leaving group into something better or try to not remove it from the reaction because ultimately they will attack back. So this E1CB here, what we are doing is we are removing these bad leaving groups in a way that they are not able to attack back, right? So what is the condition for elimination unimolecular E1CB reaction? The first condition is you should provide basic medium and a poor leaving group should be present and an acidic hydrogen should be there to be eliminated. Okay, substrate must have alpha acidic hydrogen and presence of leaving group is important. So what will happen? This is a substrate. You have electron withdrawing group. You have a leaving group, and to the beta position of it, you have alpha hydrogen and a leaving group to the next carbon. So what is going to happen? Try to see it carefully. Uh, this is your base, right? Basic medium we are providing basically. It will
Yes, sir.
abstract this proton and it will generate a positive charge, sorry, negative charge here
Yes, sir.
or not. This negative charge will push the electrons into a bond and will remove this fluorine. Now, this fluorine was initially a bad leaving group because it has been kicked out due to the negative charge. It will stay there. Suppose you can think like initially, in the initial, like while we were doing the production of haloalkenes, why we were not producing a bad leaving group there because bad leaving group was unstable. It will attack back at the reaction. But here, what we are doing, we are kicking the bad leaving group out. Suppose if I talk in Urdu, you can consider it. जब हम स्टार्टिंग में थे ना, जो हमारा लिविंग ग्रुप निकला था, वो उसको पीटा वीटा नहीं गया था, ठीक है, वो ऐसे ही निकल गया था चुपचाप, तो उसको कोई खौफ नहीं था. बट यहाँ पे हम उसको कैसे निकाल रहे हैं? विद द हेल्प ऑफ नेगेटिव चार्ज. तो यहाँ पे हम उसको पीट के निकाल रहे हैं एक तरीके से. तो ये अब जो पिट के बाहर निकला है ना, ये आराम से बैठा रहेगा. इज इट क्लियर
Yes,
why
sir.
the living group here is not attacking back? Because we have kicked them out here.
Yes,
So
sir.
this is your E1CB reaction. It will also lead to the generation of alkene. What are the main condition for this? You must have leaving group, a bad one, and electron withdrawing group and acidic hydrogen. If these three conditions are meeting plus basic medium, then you will go for E1CB. Right, this is again E1CB example. This is your bad leaving group. This is your alpha hydrogen. You have provided basic medium, right? And you have a electron withdrawing group as well. Is it clear?
Yes, sir.
Now, this is a question again. You have to tell me which one will have the best reactivity towards SN2. Tell me.
Sir,
Hmm.
sir, the second one.
See, let me give you a hint. This one is good. Why? Because we have a Cl, right?
Yes, sir.
We can attack from here. It is 1 degree. Here again, we can attack. It is a 1 degree. It is good again. And if we talk about this one, it is again SN1. This is good. But I told you something. The alpha carbonyl compounds are excellent. So this is excellent. Whenever you have like something like this, alpha carbonyl compounds, then you will have the best SN2 reaction. So this is excellent.
Yes, sir.
Okay, let me see if I missed something or not. So this is it. Now, again, I think we did this again. Now we are going to talk about reaction of haloarenes. Reaction of haloarenes. Aryl halides are extremely less reactive toward nucleophilic substitution reaction due to these four reasons. I told you, I remember. The
Yes,
first
sir.
one is resonance effect because there is partial double bond character. It is more harder to break a double bond than a single bond, so they cannot do the substitution. The different hybridization in basically haloarenes, we have sp2 carbon, and in alkyl halide, we have sp3 carbon. So which one is more easier to break? This one. So this is again a reason. Instability of phenol cation. If you have a phenol, if you are doing the self ionization and you are generating a carbocation is very unstable in phenyl ring. So SN1 is ruled out. For SN2, you have a place to attack from backside. As sp2 is planar, you don't have any side you can call a backside. So you cannot do the SN2 as well.
Yes, sir.
The last point is because of possible repulsion, less likely to electron-rich nucleophile to approach the electron-rich arenes. Our arenes are electron-rich, benzene ring is electron-rich, and if we have a nucleophile, it is also electron-rich, so they will create a repulsion. So this is again a reason. Replacement of hydroxyl group. We call it dose method as well. Okay. You have to tell me like I remember I told you this very like with so many examples. So what is happening here? We are basically introducing electron withdrawing group. What is electron withdrawing group doing? It is making my electron rich benzene ring into something poor so that the repulsion which was present there initially can be neglected or reduced. So now my
Yes, sir.
benzene ring is slightly poor, so it will accept the nucleophile's electron and make a bond or reaction.
Yes, sir.
Initially, we had only our chlorobenzene and we are reacting it with NaOH. In this NaOH, our OH negative will act as a nucleophile and attack. But what is the issue here? This benzene ring is still very electron rich. It will not react yet. It will not react yet. So if you have to do this reaction, you have to provide some extreme conditions like high temperature and high pressure, right? So the first
Yes,
step
sir.
is to convert it to oxide ion and then react it with H positive to convert phenol. But what you can do to reduce these conditions, high temperature and high pressure, you can introduce an electron withdrawing group. Once you have introduced the electron withdrawing group, it will create parts like it will make our benzene ring from electron rich to electron poor, so our nucleophile can attack. As you are increasing number of electron withdrawing group, your conditions will decrease. Like with one electron withdrawing group, you can see that 443 is required. If you have introduced two, temperature condition has dropped. If you have introduced three, you just might have to warm it. Like you have to just warm it in hot water or boil it. You will get your product. So as the
Yes, sir.
electron withdrawing group are increasing, our SNAR reaction is activated. Right.
Yes, sir.
Now aromatic nucleophilic substitution, which we call SNAR. We have two types of reaction: addition elimination and elimination addition. Addition elimination, as the name suggests, once our nucleophile will be added, then the elimination will occur. So what are the conditions for this? Nucleophilic substitution reaction of aryl halides do occur readily when an electronic factor makes the aryl carbon bonded to the halogen susceptible. This is very. Let me give you an example. Suppose you have an electron withdrawing group. If you have an electron withdrawing group, then you will follow addition elimination. First, your nucleophile will be added like this. Then the negative charge will revolve in the benzene and ultimately it will eliminate your leaving group like this. You have a electron withdrawing group. Your nucleophile will come and attack here, due to which you have a negative charge here and it will revolve in the benzene ring and it will come back and remove your chlorine. Right? This is addition, then elimination. The first
Yes,
step
sir.
is slow and the last step is fast. So how can you identify whether your benzene ring is going to follow addition elimination or elimination addition? If you have an electron withdrawing group such as NO2, then you will follow addition elimination. If you have no such electron withdrawing group, you will follow elimination addition. This is the key. You have to look for electron withdrawing group, right?
Yes, sir.
Okay, this is the order. Chlorine will attack first. We discussed this in the class previously. It is like this. See, this will attack or not. Let me
Yes,
show you.
sir.
This is a chlorine. Now, nitrogen gave its own lone pair, so it will bear a positive charge or not.
Yes, sir.
As carbon cannot make more than 5 bonds, uh, so it will shift one bond to the next carbon like this. Now I have a negative charge here. Okay. The moment nitrogen is obtaining a positive charge, it will sacrifice this hydrogen and take its electron to neutralize it. It will look like this. This negative charge will revolve and come back and remove my chlorine, and I will get my product like this. NHCH3 and N. Is this clear?
Yes, sir.
Similar for this one as well. Now elimination addition. What is the key factor that you should see whether if you need to use elimination addition? You will see absence of electron withdrawing group. Right. If you have no electron withdrawing group, you will follow elimination addition. If you have electron withdrawing group, then you will follow addition elimination. Right. Okay.
Yes, sir. Yes, sir.
So again, this is some examples, and let me give you some mechanism as well. So this NH3, NH2 negative will act as a base and will abstract this hydrogen and will convert it into benzene. We call it benzene mechanism as well. Benzene is planar, so your base. So let us not see this. We will see this one. It will abstract this and convert it into this. right? This bromine will be removed as carbon cannot make more than 4 bonds. Now we have a nitrogen NH3. This can attack from there, like here and here as well. For example, I am attacking at this position for now. So again, the bond will shift and negative charge will be here. This negative charge will abstract this hydrogen and will make my product like this.
Yes, sir.
Is this clear?
Yes, sir.
So required condition for this, unactive benzene derivatives, basically, which means no electron withdrawing group. It is favored in presence of strong base. You have to use a strong base, and temperature should be high, and alpha hydrogen should be present. These are the condition you can do elimination addition, right?
Yes, sir.
Now we discussed nucleophilic aromatic substitution. Now we will talk about electrophilic aromatic substitution. Till here, we were using nucleophile. Now we will use electrophile. Okay.
Yes, sir.
So this is our basic thing. Our benzene is electron rich, electrophile is electron poor. It will attack from its electron density of double bond and it will form a sigma complex. The charge will revolve and leave our compound. So let us see directly the halogenation. See, if you are observing Cl2 in presence of anhydrous Cl3, you will do the chlorination at ortho and para. Simply, para will be major. For nitrogen, you will use HNO3 plus concentrated H2SO4. The main nucleophile is NO2 positive, which will be created by reacting these two things. This will abstract proton and this will remove as H2O. H2O is minus, and you will get your NO2 positive and it will attack. Basically, this will be attacked like this. Major and minor, you know. For sulfonation, we will use only concentrated H2SO4. And one more thing, sulfonation is a reversible process. They will ask you in the exam which one is reversible. So you will have to say sulfonation is reversible
Yes, sir.
with water. Here the electrophile is also 3. Craft acylation and alkylation, I think. Do you remember this or not?
Yes, sir.
Are you sure?
Yes, sir.
So these are some important questions that you should keep in mind, right? Some theory questions.
Yes, sir.
And I think I am missing something. Wait a second. We have those Wurtz reaction, Wurtz fitting reaction, and fitting reaction. Do you remember what is Wurtz reaction?
Yes.
What is
Sir.
what is Wurtz reaction?
Sir, in the presence of dry ether, the reaction. Uh,
Okay.
sir, sir, alkyl halide.
Sodium in presence of dry ether. If you
Yes,
have a
yes,
methyl
yes,
chain,
sir.
it will be doubled basically. One ka
Yes,
do ka
sir.
charge. So I will add that page as well. And this is all about. I think I have added that page or not. Hmm, I have not added that page. Wait a second. What is the name of this PDF? Chapter 10. Let me complete. So this is your woods reaction, woods fitting reaction, and fitting reaction. This is all about your chapter. Please do revisions and the question that I have gave you as homework now. I will check those in the next class and we will start the new chapter tomorrow. Okay. Hello,
Okay,
alcohol
sir.
one now. Do
Okay,
you have
sir.
any questions till now?
Mm, no, sir.
I gave you a question as homework. Which one was that? I will check
Uh,
it tomorrow.
okay, sir.
Tell me now which one was that? I forgot.
Sir,
Mm, this one, right? Take a
yes, sir,
screenshot
this
of it.
one.
You have to tell me the answer for this question in the tomorrow's class.
Okay,
Right?
sir.
I will share this updated
Yes.
PDF and please go through this. This chapter
Okay, sir.
is the basics of organic chemistry. If you are able to understand it, the next chapter will be very easy for you. Otherwise, it won't. So please revise this chapter. Okay.
Okay, sir.
That's it for today. Thank you for joining me.
Thank you, sir.